So today we're going to be talking about decimals and their relationships with fractions. They're a lot more similar than we often think. So to start off, we're going to look at the decimal 275 thousandths. Now, when we're looking at the decimal 275 thousandths, I want to review the place value. So first we have the first digit beyond the decimal place. We call the tenths place. Remember, we call this the tenths place because it takes 10 tenths to make a whole. 10 of these pieces make one whole. Remember, when we're talking about whole numbers, we're talking about the numbers to the left of the decimal point, the ones, the hundreds, the thousands. Our second decimal place value is the hundredths place. And remember, it takes 100 hundredths to make a whole. And lastly, we have the thousandths place. And we know again that 1,000 thousandths make a whole. Remember that THS tells us that we're talking about decimal place value. Now, the nice part about this is that it relates directly with fractions. Let me give you an example. Let's say I had this fraction. Notice we have here a 10 in the denominator. The reason that 10 is in the denominator is because it takes 10 pieces to make a whole in this case. I have 7 pieces out of 10, so 7 tenths. If I were to write this as a decimal, I would write 0 and 7 tenths. Notice it's said the exact same way. And if we look at the previous page, remember that first digit after the decimal is the tenths place. This also tells me that if I had 3 more of these pieces or 3 more tenths, I would have 10 tenths. I would have 10 tenths. And 10 tenths, remember, would be the same as 1 whole. All right. Same idea if we're looking at the hundredths place. I see here the fraction 83 hundredths. If I were to write this as a decimal, I would have 0 and 83 hundredths. Now, one thing you might wonder is how do I know that I should have a 0 there? Well, it takes 100 hundredths to make a whole, but I only have 83 in this case. And I know I need 100. My denominator tells me that. 100 pieces to make a whole. I don't have enough. Therefore, I'm going to have 0 and 83 hundreds in this case. Now, again, if I had more, in order to get to 100 hundredths, I would need 17 more. That would get me to 100 hundredths. And again, that would also be a 1 whole. The reason it takes 100 of these pieces, but it only took 10 of these pieces, is remember the 100th pieces are much smaller. As we break something into more pieces, the pieces get smaller. They're 10 times smaller, actually. And then lastly, we have 75 thousandths. My denominator tells me it takes 1,000 pieces to make a whole. I only have 75 of them. So I'm going to say 0, and I'm going to have a 0 in the tenths place here. 75 thousandths. And again, if I had more of these, I'm going to need 925 more. That would get me to 1,000 thousandths, which again is 1 whole. And remember, these pieces are the smallest of those 3 place values: 10, hundredths, and tenths, hundreds, and thousandths, because it takes 1,000 of these very, very small pieces. Now, a lot of times we will work with fractions that have a 10, 100, or 1,000 in the denominator, and a lot of times we won't. So let's look at what happens in examples where we won't. Notice in these two denominators, here I have a 2, and here I have a 5. This doesn't align very closely with tenths, hundredths, and thousandths. Now, one thing that we can do here is we can make each of these into tenths, hundredths, and thousandths. Let me show you how to do that. Now, if I'm looking at 1/2, I know that I can easily, by looking at that 2, I can make that 2 into either a tenth, a hundredth, or a thousandth by multiplying by 5 here. Now, whatever I do to the denominator, I have to do to the numerator. One reason that's true is because when I multiply by the same thing, in this case, that's like multiplying by 5 over 5, which is 1. And remember, when we multiply a number by 1, we're not changing that number, it's staying the same. In this case, it's going to look different, but it's going to be equivalent, an equivalent fraction. So if I look here, I'm going to have 5 times 1 is 5. 2 times 5 is 10. 5/10. This is something that we can easily make into a decimal because we now have that 10 in the denominator, which aligns with our decimal place values. Same thing here, 1/5. I'm going to think, what can I multiply 5 by to get either a 10, 100, or 1,000? A 2. I'm going to do the same to the top and the bottom, which gives me 2/10. An equivalent fraction, 2/10 is the same as 1/5, which is going to look like this. So if we can change that denominator into a 10, that's great. Now, this case, fourths, remember we call fourths quarters. This is an example where there's not a whole number we can multiply 4 by to get 10. There is, though, a whole number we can multiply 4 by to get 100, and that whole number is 25. Now remember, same to the numerator, same to the denominator. 4 times 25 is 100. And if you're wondering where 25 came from, think of quarters. 4 quarters, 4 25s equals 100. I'm going to, in this case, get 25 hundredths, which looks like this. And with 3/4, same idea. I'm going to multiply by 25, multiply by 25, and I'm going to get 3 times 25 is 75 hundredths, which looks like this. And this would be the same as taking this original number and multiplying by 3, because it's 3/4, would get us up to 75 hundredths. So that's how fourths work. What about eighths? Remember that an eighth is the same as half of a fourth. As we split into this larger denominator, I'm doubling the denominator, which means I'm cutting that size of the piece in half. This gets a little tricky then. If I know that 25 hundredths is also the same as 250 thousandths, if an eighth is half of that, I'm looking for half of 250, which would be 125. So I'm going to multiply each of these because just FYI, you can't make an 8 into a 10 by multiplying by a whole number, or 100 by multiplying by a whole number, but you can into 1,000. 8 times 125 is 1,000. 1 times 125 is 125. So 1/8 is the same as 125 thousandths, which remember is half of 250 thousandths. And we can use the same thing no matter what that numerator is. So I'm going to multiply, again, the top and bottom by 125. We'll get 1,000 for my denominator. And 125 times 5 is going to be 625. So here I'm going to get 625 thousandths, and this will be the same as just multiplying this number by 5. So that's what it's going to look like when we multiply by an eighth. Now, these are usually the easiest fractions to change into decimals, besides ones that have a tenth, hundredth, or thousandth. Halves, fifths, fourths, and eighths. Now, most other, not all other, most other fractions, we kind of have to use a method of division. And the reason for that is because this fraction bar here literally means to divide. You're taking 1 and you're dividing it up into 6 parts. Now, because of that, we can also use division, and this would work for any fraction as well. I can divide 1 by 6. Remember, whatever number is in the numerator is always going to be the number we're dividing up. It's always going to go inside of that symbol. One thing I can do here is I can add a decimal and a 0, 1 divided by 6. So I know it's going to be 0 and something because it's not a whole. So in this case, I'm going to be asking myself, how many groups of 6 are in 10? That is going to be 1. 1 times 6 is 6. Subtract 10 minus 6, I'll get 4. I can continually add other zeros because that value is still 1 when I add zeros. How many 6s in 40? 6. 6 times 6 is 36. And by the way, if you needed to, you could be writing down your multiples of 6 if it helped you. 6, 12, 18, 24, 30, 36, and so on. You might need to do that if that's the case, then that's fine. 40 minus 36 is 4. Again, bring down another 0. And you're going to notice something's going to happen here. I'm going to get another 6, and this is going to repeat. What we do then is we take this number, and because these 6s are going to repeat, I'm just going to put a little bar over top of just the part that repeats, that in this case is just those sixes, that tells me that this decimal is going to go on forever. 0.166666666 and so forth going forward. So anytime we see a fraction that has a denominator that we cannot change into a 10, 100, or 1,000, division is going to be our answer. So using these methods, we should be able to go about changing any number into a decimal.